Hey guys, so we're back with our next section. So we're going to be covering our second part of our quadratics. Today we're going to be going over another way to solve as well as another way that you can look at your uh, another way that you can graph based on a different form. Okay, so let's jump right in. First off, we have quadratic functions and equations. So far you know how to solve with factored form. Now, if you guys remember, the way you solve it with factored form is something called zero product property. What that means is if we have number 1 and number 2 being multiplied together, what you're going to do is you just set each of them equal to 0. So we have x plus 2, equals 0, and 3x minus 9 equals 0. Again, that's because of zero product property. Since they multiply to get 0, each of them have to be 0, or each of them could be 0. So we say x equals negative 2, that's one answer, and x equals 3, and that's my second answer. Again, we're just solving each of the equations separately. So if I ask you what is the value of x, the answer is x equals negative 2 or x equals 3. It's either one. Now, moving on. This is another way that we can solve for quadratics, and this is what we're going to be working on today. There's a specific way, form that this looks like, and the way we're going to solve it is by using square roots. So let's kind of look at this really quickly. Now, basically, you can do this whenever there's only one x inside of your quadratic. Unlike this previous one over here, where I have 1x, 2x, I only have 1x over here, and there's no other x's in here. Now, because of that, we can use reverse PEMDAS or SADMAP. We can use inverse operations to solve it just like we would anything else. Now, for example, if I gave you something like this, 3x plus 5 equals 7, then you could solve this easily. Just get x by itself. First minus the 5. We are left with 3x equals 2. Then we divide both sides by 3, and we're left with x equals 2 over 3. That was SADMAP or inverse operations, whichever one you wanted to call it. And we're using the same principle, except all you're going to do is instead of having an x, you have this parentheses. Now, if you remember, one of the things that I said was that parentheses kind of act like barriers where they group numbers and we say, think of this as one number, and we protect it. Now, according to this, the last thing that we deal with is whatever's inside your parentheses. So the first thing we do is we get rid of any subtraction and stuff like that. So we're going to isolate this. One of the things that I said that makes life a little easier is we say, let's get rid of the things that are further. So what's further from my parentheses? Because that's the thing we're protecting. What's the furthest thing from my parentheses? And that's the 4. So let's get rid of that. So we have 2 parentheses x plus 4 parentheses squared equals 32. Now from here, all we're going to do is we're going to divide both sides by 2, because now I have to get rid of this 2, and these two things are being multiplied. So the way we undo that multiplication is we divide. So we can divide both sides by 2, and we're left with x plus 4 squared equals, sorry, I'm going to zoom in a little bit on this, x plus 4 squared equals 16. Now, from here, we're going to get rid of our squared, because according to reverse PEMDAS, we get rid of exponents first, and then finally we get rid of my parentheses. So the way we get rid of my squared is we square root both sides. That's what we talked about last lesson. So we square root both sides, and we're left with x plus 4 equals the square root of 16 is 4. Now, one thing that you have to remember is whenever you square root both sides, we have to make sure we include my plus or minus symbol. My plus or minus symbol. What this does is basically when you're doing your squares, it gets rid of negatives because a square is just the number times itself. So 3 times by 3 gives me 9. Negative 3 times negative 3 also gives me 9. So whenever you're square rooting both sides, just always put in your plus or minus. Again, I know I'm going over this a little bit more quickly. I do have a write-up on this on top of your worksheet. So if you're confused, you can look there, or you can, as always, ask me questions. But again, we're going to kind of try to keep the video a little bit more on the short side. So whenever you square root both sides, always put a plus or minus on the side without the x. Okay, that's just one of your rules. Now, plus or minus just means that it could be positive 4 or it could be negative 4. We have two options. And because we have two options, we have to split it up. So we're saying x plus 4 could be equal to 4, but x plus 4 could also be equal to negative 4. We have two options here. Now we're going to solve each of them, just like we did with zero product property. So we're going to get x equals 0 and x equals negative 8. These are my two answers. So again, it's just like how we solved by using factored form, or all we're doing really is we're just getting x by itself, and we have two answers. That's something we got to watch out for. So again, all we're doing is we just use reverse PEMDAS or SADMAP or inverse operations, whatever you want to call it. You protect your parentheses, get rid of everything else first, and when you square root both sides, you have to make sure to get rid of, or excuse me, you have to get rid of your squared, and you have to use plus or minus. Okay, that's basically it. Now, let's try another one. Now, this is where it gets a little bit unfortunate, because our rule was, in order to solve using the square root, we have to only have one x. Here I have 2x, so I'm not allowed to do it, because I can't just get the x by itself. There's no way that I can get this x by itself, and I can't combine these two either because they have different powers. So if ever you see two different x's like this, you cannot use square roots. Okay, so the way we solve this for now, I'm going to be showing you how to do this in my next video, is just no can for now. For now, again, just for now. I'm going to show you how to do this in our next video. But again, square roots does not work. Square roots only work if there's only one x. This one, however, does work. So let's kind of jump right into this. So what we're going to do is we're going to get my x by itself. There's no parentheses here, so we're just getting the x all by itself. The first thing we got to get rid of is this 6. So we have 3x squared equals 6. Then I got to get rid of the 3 because we get rid of the multiplication before we get rid of the exponent. So we divide both sides by 3, and we're left with x squared equals to 2. Now we square root both sides, square root. So we have x equals plus or minus. Now whenever I do square roots, we have to do plus or minus the square root of 2. Here's the thing. This isn't a nice number. It's not an integer. It's not a whole number. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. We don't have a nice number for the square root of 2. It's like 1.41 something, but if you want, you can always use a calculator. You can go online and go to desmos.com and figure out what it is. You can use their scientific calculator. You can also type into Google as square root of 2. But if you want, you can just leave it like this. Whenever you have a number that's not a perfect square, you're more than welcome to just leave it. That's totally fine. Your answer key will have both possibilities up there, so you're able to do whichever one you would like. All right, that's solving quadratics using square roots. Next, we're going to be talking about how to graph from vertex form. Now, if you guys remember when we did graphing, all graphing is it's just a pattern, right? It's all of our possible solutions to my equation. When we did lines, what we said is we have 2 dots and we just connect the dots. We had point slope form, slope intercept form, and standard form, and each of them gave you different pieces of information. So far, we've learned how to graph it from factored form, if it was like parentheses x plus 1 times parentheses x plus 2. But now we're going to show you something called vertex form. Now, vertex form, the reason why it's connected with this section is whenever things are in vertex form, it's really easy to solve it using your square root method, right? There's only this one x, it's number, parentheses, x plus number, quantity squared, so on and so forth. And that's just your vertex form. Now, each of these, just like when we did slope-intercept form, which was y equals mx plus b, your non-x and y values do have meaning. So let's go over what that means. A is your amplitude. Basically, what that's telling you is how much you're going to go up or down when you move 1 point to the right. It's basically telling you how skinny or how fat your parabola is going to be. So if it's a big number, it's going to be really skinny. But if it's like a fraction, it's going to be really fat. It actually also tells you whether it's facing up like a U or facing down like a rainbow. But I'll talk about that a little bit more. That's your amplitude. That's the number that's directly in front of your parentheses. Next, you have your vertex. Your vertex is h comma k. Now, if you remember, your vertex is a point, so there's an x part and there's a y part. Your x part is inside the parentheses. Your y part is outside. So let's look at this. So first off, this is in standard form. It's number, parentheses, x minus number squared plus another number. So first off, we have my amplitude. This tells me how much up or down my points are going to be. But whenever we're doing parabolas, the first thing we want is my vertex. So my vertex in this case is going to be h comma k. My h is the number that's connected, or excuse me, the number that's inside my parentheses. So I have 2 over here. I'm ignoring the negative because it's supposed to be negative. If it helps you, whatever the number is inside, you take the opposite sign. So if it's plus 2, you want negative 2. If it's negative 2, you want positive 2. And then the number outside, that's just totally fine. So it says plus 4. So then your y value is 4. That's all you're doing. What your H and K is it's just the coordinates. The number inside your parentheses, that's going to be your X component. The number outside of your parentheses is your Y component. Then we just place it 2, 4. So it's 2 to the right, 4 up. This is your vertex. Next, you're using your amplitude. And what I said is this tells you how much or up or down you move when you move to the right or to the left. This is saying we're moving 3 up if I move to the right. So if I move to the right 1 point, I move 3 up. Please be careful. This is not a slope. I'll explain why a little bit later, but this is not a slope. It's saying when you move 1 to the right, how much do you go up or down? And when you move 1 to the left, how much do you move up or down? So 3. And then that's how we get our skinny little parabola like this. Okay, that's kind of how we're graphing. So let's do this one more time, and I'll explain why it's not a slope here. Same thing. First off, we want our vertex. My vertex, my x coordinate is opposite. So my x coordinate is going to be -1. My y coordinate is going to be -4. And that's where we get over here. -1, -4. That's this point right here. Now, 3/2 looks like we're saying rise 3, run 2, but that's not what this is saying. This is saying if I move to the right 1, how much do I go up or down? So if I move to the right 1, I go up 3/2. 3/2 is 1.5. That means if I'm here and I go to the right 1, I have to go up 1.5, which puts me right here. And if I'm here, I go up 1.5, which puts me right here. So be careful. Just because you see fractions, fractions don't mean slope. Now, technically, this is like a shortcut way to remember amplitude, but because of the nature of these videos and how we're just trying to get you the general gist, it's a shortcut that kind of works, so it's okay for now. But please be careful. This fraction or this number in front of your parentheses, even if it's a fraction, that's telling you how much you move up or down if you move exactly 1 to the right. So whenever you're doing parabolas this way, you're always going to go exactly 1 to the right, exactly 1 to the left, and the amplitude tells you how much up or down you're going. Okay, last thing is if you have something like this, y equals parentheses x plus 1 squared. My amplitude in this case is going to be equal to 1, and my vertex is -1, 0. If there's no h, there's no k, then those numbers are just going to be 0. So for example, if I had something like this, y equals parentheses x plus, or excuse me, y equals x squared plus 1, there's nothing connected to my x. There's nothing inside my parentheses. So that means my x value in this case is 0 and my y value in this case is 1. So again, if there's nothing in h or k slot, it's a 0. Now, if there's nothing in front of my parentheses, my amplitude is always 1 because we're multiplying. Whenever you're multiplying and there's nothing there, there's always an invisible 1. Whenever you're adding, you can just say it's 0. All right, that's it. If you guys have any questions, as always, let me know. Make sure you guys know how to solve using the square root method, as well as how to graph from vertex form, and make sure you're able to identify when you're allowed to use vertex form, and more importantly, when you're allowed to use the square root method. And again, that's when there's only one x. All right, see you guys later. If you have any questions, let me know.